All right, graphing inequalities on a number line. That just means putting a dot on a number line where the answer goes, right? Well, not exactly. Let's say it was something simple like this. Graph this equation on a number line. Say we had 3x equals 12, and we want to figure out what x is and then put that answer on the number line. We would solve this by dividing by 3 to the other side, and we would say x equals 4. 3 times 4 is 12, so that's right. X equals 4, and if we want to represent x equals 4 on the number line, we would put a dot at 4, which goes right there. Now we've just represented our answer, x equals 4, on the number line. Easy peasy, we're done. All right, well, inequalities are a little bit more complicated than equations, than just a simple equal sign. So let's say we have 3x is less than 12, or 3x is, I'll just do one at a time. 3x is less than 12. So instead of 3x is equal to 12, now we have 3x is less than 12. And remember yesterday I told you with inequalities, there's an infinite amount of answers. Well, that's where the number line comes into play. You can represent an infinite amount of answers on a number line without putting an infinite amount of dots on there. So let me show you how this works. You have 3x is less than 12. To solve that, you divide 3 to the other side, just like you would do if it was an equal sign, and you have x is less than 4. So how do we represent that on the number line? This is saying that x, we could plug in any number for x that's smaller than 4, and it'll make that equation true. So let's check it. Let's plug in 3. 3 is a number that's smaller than 4. So you have 3 times 3 is less than 12. Is that true? 3 times 3 is 9. And then, yes, it's true. 9 is less than 12. So we did the problem right. X can be anything less than 4. So how do we represent that on the number line? Do we just pick one and say, oh, -2, there you go, that's less than 4, that's my answer? No, you don't do that, because even though you're right, -2 is less than 4, and -2 does work, we want to represent every number that works, not just one example that works. So that's where it's a little bit confusing, because yesterday they just gave you one example of a number and you had to say yes or no, does that work? Now today we don't want just one example, we want all of the right answers. So to represent x is less than x is less than +4, with all the correct answers, we have to draw an arrow from 4 to the left, like this. You can draw it right on the number line. Sometimes it's right on the number line. Sometimes it's above it. But regardless, this is saying everything to the left, which means smaller numbers, because your smaller numbers go to the left. So anything smaller than 4 will work in this problem. 3x is less than 12. So that's why there's an infinite amount of answers. You can pick anything on the number line that goes to the left forever. You could pick -10. You could substitute in -10 here. 3 times -10 is -30, and yes, -30 is less than 12, so it works. So you can pick anything less than -4. Now I'm leaving one thing off. I keep saying -4, sorry. Anything less than +4. Remember when I graphed it and I said x is equal to 4 and I put a dot right there, and I didn't put a dot this time? It's because when it comes to inequalities, you have a choice. On the number 4 here, you could put a dot, or you could put an open dot, an open circle. But you have to put the right one. You can't just willy-nilly pick one and put one on there. You got to pick the right one. So how do you know which one it is? This is how you know. If it's a dot, it includes that number. If it's a circle, it does not include that number. So our answer is less than 4. Not less than or equal to, less than. That means we cannot include 4. 4 will not work, because if we substitute in for 3x is less than 12, we substitute in a 4, 3 times 4 is 12, and 12 less than 12 is not true. 12 is not less than 12. 12 is equal to 12. So we can't use 4. That means we have to put a circle on 4. That means don't use 4, use anything that's less than 4. When would we use a dot? if the original problem was this. So, less than or equal to signs, greater than or equal to signs, use the dot. If there's just a less than or just a greater than, they use a circle. Let me erase that so you can see it. So that's how you tell the difference. If you want to include that number, meaning it can equal that number, then you put a dot. Then it includes that number. If you don't want to include that number, that means it's just less than or greater than. It's not equal to, then you put a circle. So that's how you do these problems. If it's x could be anything bigger than the number, you draw the arrow to the right. Let me show you an example like that. If it's x could be less than the number, you draw the arrow to the left. So let's say we have 3x is greater than or equal to 15. You would solve this by dividing by 3, and you would get 5, so x is greater than or equal to 5. So greater than or equal to means it does include 5. It does, so you put a dot there. And it could be anything bigger than 5, so you draw an arrow to the right, and there you go. You graph that equation. Okay, this is where it gets tricky. So let me show you this example because this happens all the time. And this is when x is on the right-hand side of the inequality. So let's say you have 15 is greater than or equal to 3x. Looks kind of just like the problem I just showed you, except now the 3x term is on the right-hand side of the problem and the 15 is on the left-hand side of the problem. Still a greater than symbol, didn't change that, just switched my numbers around. So let's solve this one. Divide 3 to the other side, and you get 5. So you get 5 is greater than or equal to x. Well, it's an equal sign, so we use the dot. It can include 5. And it's a greater than sign, so people are going to draw the arrow going to the right, and they're going to get it wrong. So this is where it gets tricky. People say, well, the last problem was a greater than sign, and you drew the arrow to the right. Why is this arrow not going to the right? It's the same sign. It's because x is on the other side. This is saying x is smaller than 5 or equal to. Or if you read it from left to right, it's saying 5 is greater than or equal to x. That means we got to pick a number for x so that 5 is bigger than it. So say 4 would work. 5 is greater than or equal to 4. 6 would not work. 5 is not greater than 6. So 6 is to the right of 5, and those don't work. 4 is to the left of 5, and those do work. So this would go to the left. All right, and this is the only time I really see students miss problems like this, is when in your original problem, x is on the right-hand side of the equation. People want to draw the arrow going the wrong way because they're just in the habit of looking at this and saying that's a greater than sign, that's an arrow to the right. That's not true. Don't just look at the sign itself, look at where x is. Is the sign pointing at x or is it pointing at the number? If the sign is pointing at x, x is smaller than the number. All right, so another way to see this is that and this mean the exact same thing. These mean the exact same thing. Even though this is a less than symbol and this is a greater than symbol, they mean the exact same thing. This is both a dot with an arrow to the left. This is saying we need 5 to be bigger than our number. This is saying we need our number to be less than 5. That's saying the exact same thing. All right? It's just two different ways to say the same thing. 5 is bigger than our mystery number, or our mystery number is less than 5. It means the same thing. It means a dot on 5 and the arrow to the left. Pick any number that's less than 5, like 4. 4 is less than 5. 5 is greater than 4. Both those are true. 4 works. All right, so be careful on that. Don't just see a greater than sign and draw the arrow to the right. It doesn't always work like that. You got to look at where the x is. Is x supposed to be smaller than your number, or is x supposed to be bigger than your number? All right, that's what you're looking at. So if you avoid that mistake, this should be pretty easy for you.